Hello everyone and welcome to the part 2 of multiplying and dividing fractions. For our first example, it is consist of a whole number being multiplied to a fraction. For the first example, we have here 6 times 3 over 4. As you can see here, we have 6. It is a whole number. But let's go back or have a recap on what rational numbers are. Now, rational numbers are numbers that can be turned into fraction, where let's just have the variables a over b, and a can be divided by b, and b should not be equal to 0. Okay, so since a whole number is also a fraction, we can turn 6, our whole number here, into 6 over 1, since 6 divided by 1 is just 6. Now, going back to our example, so we could just directly multiply 6 to 3, again on a linear pattern. So we could have 6 times 3 equals 18 over 4. But again, our fractions should be reduced to their final form. So the common number or the greatest common factor for 18 and 4 is 2. So divide both numbers by 2. So we have here 18 divided by 2 is 9, and 4 divided by 2 is 2. So this is our final answer. Another option as well, based on the given, when we apply prime factorization, so we could have it this way. 6, the prime factors of 6 are 3 and 2. So over 1, because again, 6 divided by 1 is still 6, times 3. And then the prime factors of 4 are 2 and 2. So based on this, we could still cancel 2 and 2. So we could just multiply the 3's here on the numerator. So 3 times 3 is 9, and 1 times 2 is 2. So we still got the same answer based on the given. For our next example, let's have a whole number being divided by a fraction. So let's have 12 divided by 5 over 6. Again, our divisor here is the 5 over 6. So 5 will become the denominator, and 6 will become the numerator. And our operation here, our division will turn into multiplication. So we have 12 times 6 over 5. So we could just multiply the numbers on a linear pattern right away. So 12 times 6 is 72, and over 5. And this is our final answer. Now let's have an example where a fraction is divided by a whole number. Let's just have 4 over 3 divided by, let's just say, 8. So again, 8 is a whole number, and every whole number has a denominator of 1, because 8 divided by 1 is still just 8. So reciprocate each of the number. So 8 is going to be the denominator, and 1 will be the numerator. And don't forget our operation here. So we'll have 4 over 3 times 1 over 8. Now based on this, we could still apply prime factorization if you want. Now the prime factors of 4 are 2 and 2, so over 3, times 1, and the prime factors of 8 are 2, 2, and 2. So based on this, we could cancel numbers. So 2, 2, 2, and 2. So we are left with 1, and we still have numbers here on the denominator. We have 3 and 2, so 3 times 2 is 6. So based on the example, our answer is 1 over 6. Now let's have an example here of complex fractions involving both multiplication and division of fractions. So let's just have let's have a color. 1/2 divided by 1/4 times 2 over 3 over 1 over 6. Now let's categorize the numbers first as easy as we can. So here, the numerator and the denominator are connected. They will be the new numerators as we multiply 1 and 4. So 1 times 4 is 4. And here, this denominator and this numerator will be multiplied accordingly. So this will be 2. So if you want to have it one by one, on how we do it originally, so you can have it this way. 1/2 divided by 1/4. So if we reciprocate 1 and 4, it will become 4 over 1. So let me just erase this. So we have it here, 4 over 1. So 1 times 4 is 4, and 2 times 1 is 2. So both of them are just the same. So we just made this one easy or quick as possible. So again, the green line here, the first numerator and the denominator below will become our numerator. And here are 2 as a denominator and 1 here will be the new denominator. And that's it. Let's proceed to the second thing. And just like to what we did to 1/2 divided by 1/4, it's still the same with 2 over 3 over 1/6. So connect 2 here and 6 and 3 and 1. So 2 times 6 is 12, and 3 times 1 is 3. And just copy the operation given. But we could simplify this right away. And 4 divided by 2 is 2, times 12 divided by 3 is 4. So 2 times 4 is 8. And that's it. For our last example, we have 3 over 8 times 4 over 5 divided by 7 over 12 divided by 2 over 3. So let's have steps 1, 2, and 3 if needed. So let's have first step 1. So let's have 3 over 8 times 4 over 5. So based here, we could see that 8 and 4 have something in common. So we could break 8 and 4 using prime factorization. So for 4, we could have 2 and 2. For 8, we could have 3 2's. So we have 2, 2, and 2. And we may now cancel. So cancel 2, 2, 2, and 2. So based on this, we are left with 3, and 2 times 5 is 10. So this is the result for our first step. Now for the second step, let us have step 2. So we have here 7 over 2 divided by 2 over 3. Okay, so we don't have enough space, so let's scroll down. So we have 7 over 2. Again, our division operation will become multiplication. And 2 over 3 will be reciprocated, so we have 3 over 2. So and now we could directly multiply, so 7 times 3 is 21, and 2 times 2 is 4. So this is the result of our second step. And since these two fractions, the 3 over 10 and 21 over 4, are now available, so we could now rewrite them accordingly. So we have 3, we're gonna have 3 over 10 divided by 21 over 4. And as you can see here, our operation is division. So if we write it, we could have 3 over 10. So it will become multiplication. And then 21 over 4 will be reciprocated. So we'll have 4 over 21. Now, by using some factors, so the factors of 10 here are 2 and 5. For 4, we have 2 and 2. And for 21, we have 3 and 7. So canceling such similar or the same numbers, we'll have 3, 3, 2, and 2. So what are left here are 2, 5, and 7. For the numerator, we only have 2, so we just copy it. And on the denominator, we have 5 times 7, which is 35. So from the given item here, we have 3 over 8 times 4 over 5 over 7 over 2 divided by 2 over 3. The answer, our final answer, is 2 over 35. And that's it for the day.